problem in this lesson, let's take a look at example 6 in your text. And in this example, they give us an equation and they ask us to find the slope of the line. So the equation they give us is 3x minus 2y equals 4. Now what we want to do is we want to solve this equation for y. So to do that, we need to isolate y on one side of the equal sign, all by itself on one side of the equal sign. So we deal with the terms first, and the first term we have here is a 3x, and we want to get the 3x out of here. To do that, we'll have to subtract 3x, because when we subtract 3x from 3x, we get 0. What we do to one side of the equal sign, we have to do to the other, so we'll subtract 3x on this side of the equal sign. This becomes 0, and we have a minus 2y equals a minus 3x plus this 4. We still don't have y by itself. We have this coefficient, a negative 2, in front of the y. Now to get rid of the minus 2, we're multiplying y times a minus 2, so we'll divide by a minus 2, which will give us 1y, which is y. And we'll have to divide this whole thing by a minus 2 also. So this gives us y equals a minus 3x plus 4 over a minus 2. And we can break this into two fractions. This is the sum of a fraction. This is the same as a minus 3x over a minus 2 plus 4 over a minus 2. And simplifying that, a negative divided by a negative, this is 3 halves times x. And the 4 divided by a minus 2 is a minus 2. So now we have it in proper form. And now we can construct a table of x, y values and get a couple of points. And once we know those points, we can calculate the slope. So let's build a table. Okay? A value for x, we'll make x equal to 1. And y would be 3 halves minus 2. So 3 halves minus 2, 3 halves, what's 2? 2 is 4 halves, right? So this is going to be a minus 1 half. So when x is 1, y is a minus 1 half. Let's try x equals 2. We'd have 3 halves times 2 minus 2. These would cancel. We'd have 3 minus 2, which is 1. So when x is 2, y is 1. We have 2 points, and that's really all we need now to figure out what the slope is. This is our equation. We've put the equation that we started with in proper form, and now with using this equation, we've generated these 2 points. So remember, these are ordered pairs. So we have 1 and minus 1 half is one ordered pair, and we have 2 and 1 is our second ordered pair. We'll call this point 1, this point 2. Our formula for the slope is m is the slope, equals y sub 1 minus y sub 2 over x sub 1 minus x sub 2. Now that's a different formula than I've been using. I've been using y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But I explained earlier to you that it doesn't matter which one you subtract, as long as you're consistent. If you subtract point 1, the y from point 1 from point 2, then you have to do the same with the x. If you subtract the y from point 2 from point 1, the y of point 2 from point 1, you have to do the same with the x from point 2 from point 1. So we'll do it this way this time. Our y in point 1 is a minus 1/2. This is our y value. Our y in point 2 is 1. Divided by our x in point 1 is 1. And our x in point 2 is 2, minus 2. Now, we have a fraction here. In order to subtract fractions, we have to have a common denominator. The denominator would be 2. How many halves in 1? Well, there's 2 halves in 1. So this is minus 1/2 minus 2 halves. 2 halves is equal to 1. Divided by 1 minus 2 is a minus 1. And this is minus 1/2 minus 2 halves is a minus 3 halves divided by a minus 1. That's just 3 halves divided by 1. The minus signs cancel. And 3 halves divided by 1 is 3 halves. So our slope is 3 halves. Now I want to call your attention to something that you're going to be able to use in the future. Notice that our initial formula, once we got it into its proper form, was y equals 3 halves x minus 2. And our slope was 3 halves. This 3 halves corresponds to this 3 halves. If you get your equation in this form, the number preceding the x term in a linear equation will be the slope of the line of that equation. So once you solve for y, you automatically know the slope. It will be the coefficient in front of the x term in that equation. So that's a helpful piece of information that we're going to use in the future. Let's see. I guess that would be the end then of this example, and that's it.